Hi, I'm going to present today a short presentation that was given at the Newcastle University Humanities Research Institute and Newcastle University Centre of Research and Excellence in Data workshop series in the summer of 2020. We'll talk about how we visualise uncertainty. It was partly a research project funded through the Alan Turing Institute in London, and it's about how to reliably represent limited knowledge in an image form rather than in a numerical form, and in a form intended for a general audience, so not for technical experts, mathematicians, statisticians and scientists, but for the general public and policymakers and decision makers. The talk's going to be in 3 sections, each about 10 minutes long, one on data visualization and uncertainty in the background, one on the specifics of our new research approach to this, and one on some application areas, some examples of how we might use this. So first of all, what's data visualization? This diagram we often use to describe this. Data stored somewhere in a cloud, a computing system, it's sent to a display, and an image is created of the data, and in this case it's a 3D image of data about the city of Newcastle. This image data is transferred optically, light waves, to a human, and the human being perceives them, understands them, and converts it into neural signals, electrochemical signals in the brain. That generates ideas of some kind. Most of the time in visualization we're trying to generate images that at the first instance give a consistent set of information, someone seeing them. What people think about that information it is not in our control, but we want to try and have if we set out to send some information, we want people to be able to understand it. Something worth saying is that the importance of this is growing. The gap between the amount of data available in the world and human cognition just gets bigger every day. Human cognition isn't really growing in ability, but the amount of data is. So visualization is constantly having to adjust to try and match these differences, the huge amounts of data, to the capacity of the humans to understand it. The question of why use data visualization, if we look historically, we can look for a couple of reasons. Johann Pestalozzi in the 17th and 18th century said this: visual understanding is the essential and only true means of teaching how to judge things correctly. The learning of numbers and languages must be definitely subordinated. This seems a bit harsh, but he created a method of teaching based around this that was used in Switzerland, and a number of I think, future educationalists in Switzerland came with the same ideas. And one of the pupils who learnt this way, who struggled before they started to use a visual approach to learning, was Albert Einstein, and he went to a school which taught in this way, and he would say in future that when he had ideas, he always had to see them, he had to visualize them in his mind before he could write down the formalisms and the mathematics. A second person worth noting, I think, is John Tukey in the 70s. He wrote a book, Exploratory Data Analysis. Before computers, before it was routine to have visualizations on the desktop, he used pencil and paper and said, the greatest value of a picture is when it forces us to notice what we never expected it to see. This he did before he did any formal statistics, so he would try and draw pictures first to get a feeling for the data. And the standard data information knowledge wisdom pyramid, you don't have to agree with it, but it's a way to structure thinking about how we go from raw data through structured information and knowledge to long-term understanding and wisdom is here. And what I think visualization does is it's a tool that we build that helps support faster and more accurate human cognition. And so we want to be sure that we've scientifically tested visualizations before we start using them, so that we know that they're as useful as possible to different people, and we want to be sure that they are in fact making more accurate and quicker understanding of data and data products. Cognition through images has been used for some time. I'll just pick up 2 historical examples. One is Florence Nightingale, born about 200 years ago, and 165 years ago she talked to the military about deaths in the Crimean War, and she showed using these visualizations that deaths in hospital far outnumbered deaths on the battlefield, and argued for a much better system of hygiene in hospitals as a result. I like her quote that visualization is to affect through the eyes what we fail to convey to the public through their word-proof ears. It captures some of the sense that people don't hear anymore. They stop listening, but even then you can get to them using information correctly presented in a visual form. Otto Neurath in Vienna in the 1930s invented a set of approaches to visualization that have influenced many things right through to the present day, and it's not so well known. He created the Vienna method for pictorial statistics, which he later called isotype when he moved to England before the war. This is a very iconographic, infographics type approach where he used symbols, icons to represent data. And this is just one example of that, showing the effect of the Industrial Revolution on home and factory weaving in England, going from the early days when most weaving was in the home right through to later after the Industrial Revolution when it was all in factories. He said this: "Today, an ever-changing visual stream flows before our eyes. Never before has all that we see around us altered so completely from day to day." And you can apply that probably to every day or every week since then, that we have more information presented to us visually now than we ever have had before. So uncertainty. Uncertainty in the sciences is very common. There's no absolute or permanent truth in science. People always have uncertainty about what they measure, and theories are always being replaced by new and improved theories. And this kind of is captured in this quote from Maxwell, that once you know what you don't know, you can start to look for it. So thoroughly conscious ignorance is the prelude to every real advance in science. So to scientists, the uncertainty is natural, and science is a process of capturing how much you know and don't know about things. When you start to present this to the public, and this has been a challenge, and there's quite a number of reports on this in the climate community, climate modelling and climate science, uncertainty tends to convey a sense of not knowing, rather than a sense of we know something up to a limit. They just say, well, you're uncertain about it, you don't know. Ambiguous uncertainty in particular frames information negatively, and now you can see that in the COVID pandemic as we speak, in the information about masks, which has been very ambiguous, and it leads in some people to an instinctive aversion. The behavioural scientists put this in the amygdala in the brain, a very primitive part of the brain, fight or flight response, which leads to a very aggressive response to being told ambiguous information sometimes. And I guess one of the results of this is that you see a certainty bias. Information presented in public, and policy and decision makers like certainty in the data presented to them, and a discussion of how much uncertainty is there or what uncertainty is not so common in the public domain. In the humanities, arts and social sciences, you can see uncertainty in a number of areas. You might, of course, think of this more as doubt or as critique or as critical thinking, where uncertainty is how unsure you are of something. But in archival work, certainly, there's the effect of information noise on storage over time of materials. Think of the Dead Sea Scrolls and the little pieces that were put together there. There's great uncertainty on how they fit together and where they come from, and many things like that. But also, just in a normal archive, environmental changes and archival processes, mislabeling or mistransmitting data can cause problems. In scholarly editing, there's certainly uncertainty in choosing meaning from previous texts to put into the scholarly edition. And one way around that is to transcribe independent versions and then bring them together through a manual process in resolution of uncertainty by looking back to the original. A point made by the authors Matthew Driscoll and Ella Piarazzo is that digital scholarly editions form ambiguous objects open to future interpretation, so they're constantly changeable in a way that print books are not so constantly changeable, even though, of course, they're changeable. And finally, in the social sciences, Bruno Latour, very well known for his actor network theory, observational ways of looking at social groups and social interactions. He was very sure about uncertainty being part of this and felt that, like in the sciences, the act of observation is something that could change a system. So there's uncertainty from just looking at things. And he has this nice quote that the world's not a solid continent of fact sprinkled by a few lakes of uncertainties, but a vast ocean of uncertainties speckled by a few islands of calibrated and stabilized forms. Finally, in this section, we'll talk about types of uncertainty. There are several types of uncertainty that you could identify, but two of them are important to us in our work at the moment. Aleatory uncertainty, which is a natural variation in measurements. So, for example, if you measure the length of something or the temperature in a room, each time you measure it, you'll get a slightly different measurement, and random processes will affect that. And that gives you a certain level of uncertainty of variance, so a standard deviation in a measurement. And then alongside that, epistemic uncertainty, which is a bit harder to explain, but is when we know that we could measure an uncertainty, but we don't know the value of it. It's a belief in our ability to measure things that we haven't measured. And we'll see some concrete examples of that later on.